Okay, welcome back everyone. I hope you found that video enjoyable and informative. I'm now going to walk you through an activity called Meet the Relatives. And in this activity, you'll be introduced to some of the important anatomical features that hominins share with each other. Many of these features are related to bipedalism, or walking on two legs. So while you're going through this activity, please fill out the data table that's been provided for you on your question sheet. And I'll also provide a link to the website so you can feel free to explore it on your own. Okay, so here's our Meet the Relatives activity, and I'm going to now introduce you to the 4 different species that we're going to be looking at. So 3 of these species are hominins, including Homo sapiens, ourselves, as well as 2 other extinct species of hominins. And then the 4th species that we're going to be looking at is a modern-day chimpanzee. So here we have modern humans, also known as Homo sapiens. So again, this is ourselves. Here we have a species called Neanderthals, or Homo neanderthalensis. So this is an extinct species that existed between approximately 400 and 40,000 years ago, and actually coexisted with modern-day humans for quite a while. Then we're going to look at Australopithecus. So here we have the species Australopithecus afarensis. The most famous fossil of this species is nicknamed Lucy, and so Lucy is the skeleton that we're going to be looking at in this activity today. So this species existed between approximately 4 and 2 million years ago. And then we have our modern-day chimpanzee, also known as Pan troglodytes. And so modern-day chimpanzees are often used as a comparison for early humans and modern-day humans to help us think about our own evolution and the way that we've changed through time. All right, so here are 4 species standing side by side, and you can take a look and compare their anatomy. You'll probably notice that there's some pretty striking differences among them. And here on your data sheet, it asks you to indicate whether or not the species has long arms. So for this, we're going to say either yes, no, or somewhat. And the reason why this is important is because long arms is often an indicator of climbing trees. So it tells us a little bit about the way that the species moves around in their environment. So first thing I'd like you to do is compare the modern human, Homo sapiens, with chimpanzees. And if we're using these 2 as an example, what would we say? Does the modern human have long arms? Yes, no, or somewhat. And we'll do the same for the chimpanzee. So you may want to pause the video here for a minute to fill out your data sheet. And once you've done that, we're going to also compare the Neanderthal and Australopithecus. So again, same thing. We're going to just compare to the chimpanzee, say whether or not the species has long arms. So yes, no, or somewhat. We can also look at our species in profile. So here again, if you take a look at the modern human and the chimpanzee, you should notice that there are some pretty interesting differences relating to the differences in the way that we walk around. And so as we're going through this lesson, I'd like you to think about when we're comparing Neanderthals and Australopithecus, do they look more similar to what we see in modern-day humans, or do they look more similar to what we see in chimpanzees, or perhaps a combination of characteristics from both species? Now we're going to zoom in on the skull. And the next question on your data sheet is to think about whether or not the species has a large brain. And so again, the reason why this is informative is because it allows us to think about the intelligence of the species. So brain size is often used as a proxy to think about intelligence. And so this may be a little bit easier if we actually flip the skulls over into profile view. Okay, so now we have all of our species in profile, and what I'd like you to concentrate on is here, the size of the brain case. So this is the part of the skull that houses the brain. So again, first thing we're going to do is we're going to compare the human and the chimpanzee, and we're going to say large brain, yes, no, or somewhat. Okay, so if we're comparing these 2 to each other, what do we think the characteristics are for each of them? And then again, once you've done that, I'd like you to also look at the Neanderthal and Australopithecus and compare with the chimpanzee and see what you think. Does it have a large brain? Does it not have a large brain, or does it have a somewhat large brain? The other thing that we're going to look at here is how much the mouth sticks out in comparison to the rest of the face. So here, if you take a look at modern humans, Homo sapiens, you'll notice that the mouth actually doesn't stick out much past where the nose would be. And this is very different from what we see with chimpanzees that have a very projecting face. So again, we're going to put on our worksheets whether or not we think the mouth sticks out. So yes, no, or somewhat. And then again, we'll compare with Neanderthals and Australopithecus. So now we're going to move on to the next part of the body. So now we're going to be comparing the pelvis. So the pelvis is what we call the hip bones. And just to help you orient and understand what we're looking at here. So these are the sides of the hips. These are the hip blades. So this would be where if you touch the side of your body, you can actually feel those bones. And over here are the hip joints. So this is actually where the legs would be attached to form the hip joint. So I want you to take a look again at the modern human and the chimpanzee. So one of these species has a pelvis that is short and wide. The other has a pelvis that's tall and narrow. And so again, the reason why this is an important characteristic is because having a short and wide pelvis is actually very helpful for walking bipedally or walking on two legs, because it'll actually hold up the internal organs while you're standing upright. Whereas an individual that is walking on all fours doesn't need to hold up their body weight in the same way. So once you've looked at the human and the chimpanzee, again, let's compare the Neanderthal and Australopithecus and think about whether or not these species would have been bipedal. In other words, whether or not they would have been walking on two legs. I'm now going to rotate the pelvis to the side so I can show you another interesting characteristic. All right, so again, just to orient ourselves, these are the hip blades, and here would be the hip socket or the hip joint. And so one of the things that you might notice is that in modern humans, the hip blade actually comes all the way around to the front of the body. So you can actually touch your hip bones at the front of your body. A chimpanzee would not be able to do that. And again, what this does is it creates sort of a bowl formation in your pelvis, and that is very useful for holding up the internal organs while you're standing upright. And so again, let's think about how this compares to what we see with Neanderthals and with Australopithecus. Now, let's move on to looking at another part of the body known as the femur. So the femur is what we call the upper leg bone or the thigh bone. And I'm going to actually stop my video right here for a minute just so I can get these in a good orientation. All right, so we've got our femora here in a good orientation for us to compare. And on your data sheet, one of the things that it asks you to look at is the femoral head. So here, this part of the femur, or the thigh bone, is what would attach to the pelvis to form the hip socket. Down here is what would form the knee joint. So the femoral head is this joint right over here. And one of the things that I want you to think about is how big the femoral head is in relation to the rest of the bone. So having a large femoral head is useful, again, if you are bipedal or walking on two legs, because it helps to hold up the weight of your body. And so you should see a difference in the size of the femoral head in a modern human compared to a chimpanzee, right? And again, remember, modern humans walk bipedally, chimpanzees do not. So how would you compare what you see then in Neanderthals and Australopithecus with what we're seeing in the modern human and the chimpanzee? And again, you may want to pause this video for a second just to go fill out the data table. The final part of the body that we're going to be looking at is the foot. And again, I'm just going to pause the video here for a minute so I can orient the feet in a way that will allow us to compare them. All right, now that we've got our feet in a good orientation, I just want to point out a few things to you. So one thing to note is that not all of these feet are from the same side of the body, so they may not look exactly the same. So for example, this foot here is a right foot, this foot here is a left foot, this is a left foot, and this one I'm actually not entirely sure. So you may be wondering why the foot for Australopithecus looks so bizarre. The reason is because we actually don't have a complete fossil foot for this species. We have several isolated bones, and so that's what's indicated over here. We also have fossilized footprints, and so we have a pretty good sense of what the shape of the foot would have looked like. And this is just a reconstruction of what a scientist or an artist thought that the foot structure would have looked like. What I want you to think about here is the shape of this big toe. So we're looking at whether the toe is opposable or not, or somewhat. Opposable means that the toe is sticking out and can touch the other toes on the foot. So similar to what we see in our hands, our thumb is opposable. Our thumb sticks out, and we can actually bend it in a way that allows us to touch the other fingers on our hands. We don't have that capability in our feet, but some species, like chimpanzees, actually do. So if you notice here, the chimpanzee has a toe that is sticking out, which makes their feet look very similar to our hands. And so I want you again to think about what we see with Neanderthals and what we see with Australopithecus, and whether the toe looks like it would have been opposable. The reason why this is important is because having an opposable toe can help you while climbing trees, but actually would not be helpful at all while you're walking bipedally or walking on two legs. And so we're going to be thinking about these different species here and whether or not they have feet that look like a tree climber, or whether their feet look more similar to a modern human and would indicate bipedal locomotion, or walking around as a biped. Now that we've had a chance to compare all of the important skeletal features, the last question on your data table is to think about whether these species are bipedal. So again, there are three options for you. You can either say yes, no, or somewhat. Somewhat would mean that you see a combination of characteristics that indicate bipedalism, but then maybe also see some characteristics that indicate that the individual is still climbing trees. And so I will leave this up to you to decide based on the data that you collected. So again, think about the shape of the pelvis, think about the shape of the femoral head, whether or not the toe is opposable, and all of these should allow you to figure out whether your species was bipedal, not bipedal, or somewhat bipedal.